Everyone, my name is Antonio Nathaniel, and today in this particular episode of Crash Crash Technical Drawing course. So in this episode, we are going to be talking about a guideline or map through this course, what it will entail and how it will go. And this is an essential episode so that you will have the guide through all the topics and all the things we'll be covering for secondary school technical drawing. So once again, I welcome you back to Global Education Zone, and grab a pen and paper and jot these things down so that you'll be able to follow them along through this course. So we have two sections: plain geometry and solid geometry. In plain geometry, we're starting with lines and lettering and line work. So lettering and line work will be the first thing we'll start from in plain geometry. And lettering and line work is all about how you use lines. We're talking about drawing layouts. So your drawing layout is how you arrange your drawing on your paper, on your board. Maybe just like when you mix up your border lines or your title blocks, that's called a drawing layout. Next, we're talking about lines and angles. Lines is basically a point, a line that connects 2 points. A line is basically something that connects 2 points or 2 planes. So those lines, we're talking about them, and angles between lines. Next, we're talking about angles. Yes, we'll focus on angles after lines. So and then in our angle section, we're talking about different types of angles: your acute angles, your obtuse angles, your reflex angles, and how to construct these angles and how they are applied in technical drawing. Next, we're talking about triangles. So triangles, they are typical in technical drawing. They are special in that you can circumscribe or you can inscribe a triangle with a circle or any other polygon of your choice. Then next we have the circles. So when we're talking about circles, we're talking about how they are constructed and how they are constructed in conjunction with other polygons and shapes and geometric shapes. And also we're talking about circle geometry a little bit. Then next we have tangents. When we talk about tangents, tangent is all about how these lines cross the circles, and the tangent to the circle is always 90 degrees. So we'll be exploiting that and making use of that knowledge. Next we have collaterals. When we talk about collaterals, there are any shapes that have four sides, but it does not necessarily have to be equal. So we'll talk about those shapes. Then next we have polygons. Polygons is a shape that has more than 3 sides. So polygons include your pentagon with 5 sides, your hexagon with 6 sides, your heptagon. So we'll be constructing this, and then we'll be doing a lot of wonderful stuff with them technical drawing. Next we have arc length. Arc length is basically the length of a portion that has been cut off from a circle. So you know a circle has a circumference. Now when you cut a part of that circumference, you get an arc. So we're talking about how to construct this arc, the centers of arcs, and all the rest. Next we have perpendicular to a line from a given point outside the line. So when we talk about perpendicular to a line from a given point outside the line, is a drawing construction that you have to draw a line at 90 degrees to another line. So we'll talk about that. Next, we have division of the circle into 12 equal parts. We also talk about that where you make use of two main construction, different methods. We'll talk about different methods, but I'll talk about the 2 main construction methods, which is the division of the circle into 12 parts. So then we have next we have plane scales. Plane scales. There we go. Plane scales. This is a concept that is exploited in students in colleges and universities because scales help us to represent real life drawing on paper. We'll talk about that. Next, we have octagon in a square, general method for drawing polygons. We talk about octagons in squares and how we draw polygons, the general method. So you can draw polygons by drawing a circle, and then you can inscribe a circle with a polygon. Next, we have inscribing 4 equal circles in a square. So this is another method, another topic we're talking about. So how to draw 4 circles into a square. That's what we're talking about here, and it's just a very simple method. So you can always remember it. Next we have inscribing 3 equal circles in a triangle. So this is also a simple method which often involves bisecting the lines, the angles of the triangle or the line, and then locating the centers of the circles. Then next we have circles to touch straight lines and arcs. So you can draw circles that will touch other lines and arcs. So in this section of this episode, talk about how to draw circles that will touch lines and arcs. Next we have after that we have can inscribe a circle into any polygon. Last year I talked about a polygon being a shape with different sides, right? So you can always inscribe this shape with circle. I will talk about that. Next, we also have continuous curves and straight lines. So how to draw continuous curves and straight lines, or circle to pass through three given points. So when you have continuous curve and straight line, when you have a circle passing through a point, that's also it. Then we have tetrahedron, octahedron, dodecahedron, and icosahedron. So for example, a tetrahedron has 4 sides, and icosahedron has 20 sides. So we'll talk about all these polygons. So next we have scale of curves. Scale of curves is a very, very important topic in technical drawing because it allows you to draw angles without your protractor. So we'll be exploiting this topic and make sure you understand it because you can apply it to draw angles in examinations. So next we have the prisms and pyramids. So prisms and pyramids. Prism is basically any shape that has where the top and the bottom are identical. While the pyramid has a tapering, all the heights taper to the point. Next we have conic sections. Now this is a very important topic, and when I was in secondary school, this was my best topic because it was an intersection between technical drawing and further mathematics. So you talk about ellipses, parabolas, circles, hyperbolas, and they have interesting construction methods. Next we have section of prisms and cylinders. So in sections of prisms and cylinders, we'll talk about when we cut through prisms and cylinders, what shapes do we get? So that is what all that's about, and their construction methods. Next we have end elevations of prisms and cylinders. So when you look at these prisms and cylinders, when they intersect, how do they look from the side? How do they look from the front, from the back? Those are end elevations. So that's what we're talking about. Then we also have development of prisms, cylinders, pyramids, and cones. So development is basically when you take a shape and then you represent it on a plane surface, just like you open a carton of biscuits or a pack of goods or products. So that's how it's developed shapes. Next we have ellipse. So yeah, we'll talk about conic sections, but now we're talking about ellipse in particular detail. And ellipse has different methods of construction which we'll be exploiting in that section of this course. Then next we have diagonal scales. Diagonal scales are they take off from our plane scales, and they are a little bit more technical than plane scales, and they are a little bit more advanced and more applicable than plane scales. We'll talk about the construction and application of diagonal scales. Next we have describing any irregular polygon in a circle and drawing the irregular polygon when giving the diagonal. So how you describe any irregular polygon in a circle, and when you draw, how you draw a polygon when they gave you only the diagonal. So it's possible. Next we have triangles. We talk about triangles specifically, and under triangles we talk about their construction, how to construct them when you are given the base, when you are given the altitude, when you are given the angles, and so on and so forth. It's very interesting parts, triangles. Next we have circles and arcs. So we are back to circles and arcs. Then we'll talk about, in this part, we'll talk about how you draw circles and how you construct arcs and how you find the length of an arc, so on and so forth. Next we also have ratios and proportions, enlarging and reducing figures, and areas of figures. So yeah, we'll talk about the fact that you can also reduce and enlarge figures in terms of their length, in terms of their area. So there are methods for length and there are methods for area, which will be treating in this part. Next we also have circles to touch two lines and an arc. So how do you draw a circle to touch two lines and an arc? And how do you draw a circle to touch three arcs? Yes. And then at the same time, these circles were also touching themselves. So how do you draw them? So this is what we're talking about. Next we also have spheres. So spheres and sections and elevations and development of pyramids, cones, and pyramids and prisms. So first we talk about spheres. So spheres are basically the three-dimensional projection of circles. Then after that we're also talking about sections and end elevations and development of pyramids, cones, and prisms. So these are basically three-dimensional shapes represented in two-dimensional by orthographic or asymmetric drawing. So we're talking about these two. Next we also have lines of intersection and development. Now this is a very interesting part of technical drawing because it is applied in your different sections of technical drawing, and it is very, very important as a skill before you can be confident in taking an examination. The next section of our course will be on plane and solid geometry. And next, the first thing we're talking about is trays with sloping sides. So trays with sloping side, how do you draw a tray with sloping side? How do you draw a a sloping surface on the end elevation. So next we're talking about roofs. So when you see a roof, how do you draw the true length? How do you draw the plan of the roof? Another aspect of the roof. That's what we're talking about on that roofs. And you can even apply it in your building drawing section of technical drawing. Next we have inclined solids. So inclined solids are basically solids that are not vertical. So they don't have a perfectly vertical altitude. So you can talk about those and this part. So next we have auxiliary views. Auxiliary view is basically when you look at an object from an angle that is not an isometric or an oblique angle. It is neither asymmetric nor oblique. So there are special ways and it's very interesting. It comes out virtually in most wide examinations. Next we have lines in space. Lines in space is a very important part of technical drawing, and this is where you take technical drawing to the two-dimensional place, and then you also use that knowledge to find the true length of triangles. Then we have traces of planes. So this is where we talk about vertical trace and horizontal traces. Now this trace of plane is quite interesting and it involves lines in space, so it is in conjunction with lines and triangles. So next we have curves of intersection of levers and connecting rods. So here you have to talk about the curves of intersection of various things. That's where you talk about the rules of tangency, how to draw compound shapes like pliers and so on. So I will also give examples. Next we also have arches. So these arches, are basically curved surfaces. So they are a combination of lines and arcs. So to form various architectural designs. So we're talking about those two. Then we have moldings. Moldings, they are basically different arch types. So you talk about those two. How you draw different shapes of arcs. Just like your Corinthian column, it also have a specific arch that it was made of. Next we have loci, helix, cycloid, epicycloid, hypocycloid, archimedean, spiral, involutes of the circle. These are basically the parts that we're talking about, those sections that take off from conic sections. So just like your archimedean and spiral, talk about that. Next we have tangents of the cycloid and involutes. So involutes of a circle, we'll talk about how to draw a tangent to a circle and the involutes of a circle. So next we have parabolas. So here we're talking about parabolas specifically, and we're talking about the construction methods, and we're talking about how to find different parameters in a parabola. Next, after this, we'll talk about hyperbola. Hyperbola is basically talking about the fact that a parabola taken into another dimension is just like a parabola, but it's double. We're talking about that in this section of hyperbolas. Next, we have development of hemispheres. We're talking about that. Next, we have development of oblique pyramids and cones. So how do you develop oblique pyramids and cones? So as I mentioned earlier, oblique shapes are shapes that are not at a perfectly vertical angle. So we also have various methods we use to develop those. Next, we're talking about lines of intersection. So these lines of intersections, they are the way different shapes intersect together to form compound shapes. We're talking about those in this section. So after lines of intersection, we're talking about spheres pierced by a pin. So when you pierce a sphere by a pin, what compound shape do you get after that? So we're talking about that too. So after that, we also talk about two spheres and a cylinder in contact. So when you have two spheres and a cylinder in contact, what compound shape? How do you locate their centers? So that is also one thing we're talking about in this section. Next, we'll talk about the engineering drawing. So engineering drawing is a section under plane and solid geometry. So it's a new section. Engineering drawing, we're talking about how to draw different components, such like your screws, screw threads, your different types of screws, and even different building drawings. So that's engineering drawing. We'll also talk about that. Next, we have isometric projection of rectangular and non-rectangular objects. So how do you draw the isometric projection? And isometric projection, just in case you don't know, are drawn at 30 degrees to the horizontal. So we'll talk about that and we'll talk about different examples. Next, we have first angle projection. Specifically, first angle projection is a type of orthographic projection that is used in most British countries. So we'll also talk about that. Next, we have sections in first angle projections. So section is basically when you cut through a hard material or a material that has mass. So and not just ordinary space. So there are different things you have to section, there are different things you don't section. So we'll talk about those. Next we have isometric projection of circles, curves, and rectangular objects. So this here we talk about isometric projections, how you draw circles, curves, and rectangular objects when you want to draw the isometric projections. Next we have oblique projection. So an oblique projection, how do you draw an oblique projection? An oblique projection is at 45 degrees. So, and there are different types, just like your cabinet and cavalier oblique projections. We're also talking about that under section of oblique projections. Now, in another section of engineering drawing, we're talking about sections of webs, nuts, and bolts, and washers, screws, set screws, rivets, and shafts. So a rivet is basically that thing that's used to join two parts of components. Next we have third angle projection. How do you draw the third angle projection of your components? So it is just like first angle projection, but your plan will be above instead. Next we also talk about then I'll also give you examples in objectives. So that is really multi-choice questions. So talk about different objective questions that can be set from your objective in technical drawing, and they can be set from anywhere. They can even include mathematics. So we'll talk about how to approach these questions. Next, we're talking about freehand sketching. Now, freehand sketching is quite easy. You just have to relax and how to master your hands. Just as the name implies, it's free. So you have to make yourself free and give yourself the free will to express your abilities. Next, we have exercise on square paper and isometric grid. So using square paper is just an extension of how to draw isometric drawing. So basically, square paper, you have to draw the length along the square line and the diagonals. Next, we have screw threads. A screw thread is basically the part that is traced by those lines around the cylinder of a screw. So we're talking about those two. Next, we have conventional method of drawing screw threads. So there are different methods you can use to draw screw threads, and different types of threads, just like the buttress thread and so on and so forth. So we're talking about this in this part, and it's under mechanical drawing or machine drawing, and it's a very interesting part. We're treating every detail on this part. Next, we have dimensioning. So how do you dimension your figures? There are different methods. You could decide to use your chain dimension, you can decide to use your datum dimension, or you can decide to use your mixed dimension. So we'll talk about all this. Next, we have abbreviation and paper sizes. So abbreviations used in technical drawing, you will see something like ISO 505, ISO 307, and so those are standards that are used by engineers. So we're talking about this. Next, we have nuts, bolts, washers, rivets, set screws, conventions, bearings, springs, and so on and so forth. So these are the conventions used in technical drawing, and also electrical symbols, building symbols, machine symbols, etc, etc. Next, we also have chain dimensioning. We'll be talking specifically on chain dimensioning. Here we'll be discussing how to draw the dimensions of objects using different methods, and we also talk about the rules, the guidelines, the do's and don'ts of dimensioning. So next, we also have datum dimensioning. Just as I mentioned earlier, it's also another type of dimensioning. Here you have your approaches, you have your do's and don'ts, and then you also have your dimension lines, how to write your figures, and so on and so forth. Then next, we have conventional representation of materials. So materials is a kind of part on engineering part, and then you talk about that earlier, later in college or university, but in the secondary school level, we talk about the representation of materials. So first, next we have machining symbols. So machining symbols, this is under mechanical engineering, or rather, let's say a machine drawing. So these machining symbols, how to draw the parts of machines and represent them using symbols in drawing. Next, we have tolerances. So tolerances is that part of technical drawing that is kind of a little bit evasive and not really common in examinations. But then we're talking about that in this video, so you can stick around if you want to gain an extra edge over your mates or your colleagues, so you can be like the universal technical drawing guru. Next, we have tolerances. So tolerances is basically the amount of load, stress. So they are the representation of these stresses. So next we have electronic symbols. Electronic symbols, just as I mentioned earlier, this part is under conventions used in technical drawing. We talk about these different symbols and how to draw them, how to represent them, the different methods. Next we have electrical circuits. The electrical circuits deals with the fact that your electrical devices, they work on different circuit patterns. So you have to talk about those circuits in engineering. Next we have, lastly, we'll also be talking about forces. So forces, this is also under machine symbols and so on and so forth. So the forces on particular components and all the rest. So these are all the sections we'll be talking about in this video, and hopefully I'm optimistic that this will be an interesting course. So stick around through all this course, download the course and enjoy the course, and give me feedback so that I can improve this channel and continue to give educational and quality videos. Thank you for watching. Don't forget to like, share and subscribe.